Should we start? Yeah. I'm just waiting for a signal from you.
You want me to do it?
No, I'm waiting for like a heads up. All good?
He's out there doing something else.
All right, folks. The next topic of the day is we're going to talk about how you can get rid of your dirty little secrets that we'll have in our infrastructure and code, and how we can switch to SPIFFE and how SPIFFE helps to solve this. It's kind of conjoint presentation between me and Arvind. We collaborate a lot sometimes not, through the community. And my name is Eli Nestor. I'm sure some of you seen me through Slack and some community presentation and here and there. I'm also a co-founder and CTO at a company called SPIRL, where we build in workload identity platform. And shoot me an email here where you can follow me up on GitHub, where sometimes I put some half-baked projects to get on ideas. And sometimes I write on Twitter, now X. And Arvind, how about you kick it off next?
Yeah, sure. Thanks, Eli. Hey, folks. My name is Arvind Tirunarayanan. I'm a security engineer at Confluent. Confluent Cloud provides managed Kafka along with various other services in its ecosystem. It gives our customers event and data streaming as a service. So I'm part of their platform security team. I've been with them a little over 4 years now. And over my years there, I've worked on various parts of their security stack, including role-based access control for authorization, as well as various parts of their authentication framework. This includes both internal service authentication and customer-facing authentication, right? So speaking of customer-facing authentication, next slide, Eli. All right, so one of the major features we released last year was support for OAuth OIDC for accessing our cloud resources. Why do we release this feature? We've long provided access for our customers through identities that were mastered in Confluent Cloud. What this means is our customers would log into our cloud, they create users and service accounts and create static secrets for those and use those to access their resources in our cloud, right? But now with this new feature, we can finally allow our customers to master their identities, their application identities and their own identity providers. So this has the additional benefit of allowing our customers to shift from the usual long-lived static secrets, the dirty little secrets that Eli was talking about, to short-lived customer-minted JWT tokens from a standard OIDC provider like Okta or Azure. So no more dirty little secrets. That's a big turtle that we removed, right? But does this truly solve our static secrets problem? Next slide. So let's take a look at how a customer would normally access Kafka through Confluent Cloud. This is an example Kafka client configuration. We got your standard properties, which cloud host, token URL for getting a token, what SASL mechanism, etc. And right here, what do you see? Again, static credentials, right? The turtle underneath the turtle. So what can we do about it? Confluent Cloud started looking into SPIFFE and SPIRE as a solution for our own internal service-to-service authentication. And as we started working with it, we came to realize something really cool about SPIRE servers. Daniel referred to this a little while back in his presentation. SPIRE servers can expose their bundles like a regular OIDC compliant JWKS endpoint, right? So it's pretty cool. So next slide. If you look at Confluent Cloud's configuration page for identity providers, you see we can just use SPIRE servers, issuers, and JWKS URL right there in the OIDC provider setup. And then it behaves just like any other OIDC provider. You get your tokens from it, et cetera, et cetera. So once you've added your SPIRE server on the Confluent Cloud side as a trusted identity provider, let's see what you can do on the client side itself. Next slide. All right, so you can use the SPIRE infrastructure to fetch your token, use it in your Kafka client configuration. Now, you'll see here the same sort of configuration that I had before, except instead of the token endpoint URL, what I have here is just a pointer to a local file. And you can populate this file with the token out of band, however you want. I've had an example here where you see I use the SPIRE agent to the CLI to fetch a token and then invoke the Kafka CLI. But this token can really come from anywhere. Maybe you have a side process or a sidecar that periodically refreshes the token file. But the point is, your application doesn't really know about it, right? It just reads it from the file, and it can just use it. And again, more importantly, no more static secrets in your config. Hopefully, the last hurdle. So that's an example of how you can use file-based, a file containing a token. But you can do more with it, right? What more can you do with SPIRE and Confluent? I'll hand it off to Eli to go more into that.
Perfect. Yeah. So this is thank you for this. And as far as I remember, Confluent also a big SPIFFE and SPIRE user. Like we had a presentation this year earlier from Mohammed, who've been talking about how they run Inspire internally with, I think this is biggest to me known like number of Kubernetes cluster at scale. I think you've been talking about like 1,000 or 1,000 across different Kubernetes clusters, across different cloud service providers, which is pretty impressive. Yeah, and just to summarize a different way or how your journey might look like from, hey, today I have to deal with API keys, and tomorrow how do I get to tomorrow where like my Confluent application, Kafka client can talk to workload API natively, right? And this is the first step. What you can do is to, as Arvind showed, is you can have a Kafka library that can talk to a server bot. You need a client ID and client secret for this to authenticate. And it's kind of, you make things better. It's no long-lived API keys, but you exchange it to long-lived, like a client ID and client secret that you need to get from your OAuth server. And you still need to deal with something like a secret manager, right? So it's kind of getting this situation between consumer workload that using Kafka client and Confluent Cloud, for instance, where brokers are better because there's something in the middle, still the secret, it is rotated, right? It's short-lived. But if anyone get client ID and client secret, it's not making the situation better. So what's the next stage could be, as Arvind showed, you can use a JOT token that you can read from file system. You can aspire for this, which will be right in it somewhere, probably with something like a SPIFFE helper. But you can use something like a service account if you run in this in Kubernetes, because service account is just like a file-based JOT token in there. It would work, but it produces different issues because like each Kubernetes cluster has its own JOT issue. So now you need, if you use a platform, you need to add each additional Kubernetes cluster you have as YDC provider. So if you have like one, it's fine. If you have 10, managing of these became like really kind of burden on you as a platform team. So I've been thinking how we can make it easier without like imagine you want to use this, but you can't go to all your engineering teams and say like, hey, use this SDK, and you have like hundreds of applications. So how we can do something like this without needing for them to change the code, just only change configuration and talk to workload API natively. So I built a quick prototype that I call a SPIFFE proxy. Basically, it's kind of similar to the idea of SPIFFE helper, but it is proxy that expose an API. This is like only a local host API. So if you can run these two things in a container, this Kafka client can talk to SPIFFE proxy as YDC server, like this OAuth server. And the SPIFFE proxy does need to know client ID and client secret because they're essentially running in the same pod or on the same node, if that's like a legacy way of running things, and can talk to workload API token that get jawed back and authenticate. So in this case, you're kind of removing this need of having any static secrets in your system, but you're also removing a need for you to integrate like SPIFFE SDK, for instance. And you can use a Go SPIFFE SDK, or you can use a Go Java SPIFFE SDK, but for some languages, we do not have many support, like for Python or for JavaScript. So this approach would work like for any Kafka clients that you use without any code changes. And over time, you can migrate some of these applications to use SDK, like Go SDK natively. And Arvind has very exciting news here.
Thanks, Eli. Yeah, keep in mind this example here is more pseudocode than actual code. I removed most of the error handling to make it a little simpler, but it should give you a good idea of how you can call into the Go SPIFFE SDK from your own Kafka client code if you're using Golang. You can see here I've created a new consumer. This functionality is provided out of the box by Confluent's Kafka Go SDK. When you pull the consumer, you can get either messages out of it, like you would for a regular consumer from a topic, but you can also get a bare token refresh event. So this happens generally on startup or whenever your token goes past 80% life. And when this happens, you can just catch that and call out to a handler where you just call into the SPIFFE workload API to get a new SVID. You can add any extensions like here I've shown the logical cluster and identity pool ID. This is just part of Kafka's regular protocol. But then that's it. You attach this token onto your client and it just uses the new client from then onwards. So this is the existing functionality for our Confluent Kafka Go libraries. And for more detail, you can see the example that I've linked here on the slide.
Yeah, so just to make it clear, it's not like fully integrated Go SPIFFE SDK into their Kafka Go library. It is like a handler. You can extend this handler to make it easier to use Go SPIFFE SDK. What about Java, by the way?
We're thinking about it. It's no plans yet.
Yeah, so maybe we need to I know that Java's Kafka library is more commonly used than Go. So if you need this support, if there is an issue opened on Kafka side, you can probably ask for this to be implemented faster, like in a similar way, like it's implemented in Go. So I can have this implementation natively with the code changes. But yeah, so I want to do a quick demo to demonstrate this example with a SPIFFE proxy, where we don't need any code changes. We'll do only configuration changes for workload. And how much time I have?
You have 5 to 10 minutes.
Yeah. Louder.
Louder? Yeah. Okay. All right, so in example which I show, by default, we use authentication with Confluent, with Kafka client using username and password. This is like a standard way where you put your API keys. And then the thing that we're going to change is basically similar configuration that Arvind shows. This token and point URL is basically the address of your OAuth server. And we're going to use this local host because in a pod, we're going to run this SPIFFE proxy that's will listen on port 880. And because it's in the same pod, we don't need like any client ID and client secret. We'll attest the whole pod itself. So we don't care about these values, but we need these values to be passed to the Kafka library, like specifically that pool that we need to create on a Confluent side. Oops, That's two. I still need to reshare that my whole screen. Can you see my screen? Okay, awesome. So that's the current configuration. And what I'm gonna do, start all these things. And so what we see here, there's like a producer app that's running in its own namespace, and there is a consumer. I didn't write these examples, I just got them from what Kafka has. And it's pure Java code, so I don't do any changes there. And what we're gonna do is, okay. So we need a SPIFFE trust domain. And at SPIRL, we build fully managed SPIFFE implementation. So I'm gonna use it because it's easy to have some OIDC endpoint in internet, and we're gonna use that one for the sake of demo, but it could be this OIDC, and you need to figure out how to put this OIDC endpoint into internet, so Confluent can reach it out. I have a few trust domains, but I'm gonna use this one that's called acme.corp. And what we really need is this OIDC endpoint URL. So what it will give us, basically this data. And on Confluent side, I'll need to log in and add it as identity provider. So my SPIFFE trust domain will be an identity provider that's we're gonna use here. Acme.corp, and we need an OIDC discovery URL so it can parse it and validate it safe, and we have our identity provider with some provider ID. So the next thing we need to do is to add an identity pool, but before we do this, we need to, we don't have anything in the cluster we have. So here's a Kubernetes cluster. You see that Kafka producer is crashing and in a loop, because what it just produce a few records and it exit and Kubernetes restarting it. So what we want to do is to add this Kubernetes cluster to a trust domain. And we're going to use a SPIRL call for this cluster add, and we call it Confluent demo. Acme.corp. I'm going to say that this is a platform Kubernetes. And I'm going to select this cluster we have, and it's installed. And here you can see that there are some components that we provide installed. It has an agent that's basically exposed workload API and a controller that helps to do some management of workloads and injecting of workload API, so it gets easier. So we have our SPIFFE workload API Kubernetes cluster now, and we want to add a pool. And to add a pool, we need to do one little thing. Domain. So to add a pool, we need to specify a name. We want to call it consumer, because we want to mess with the consumer part of the Kafka And in attributes, like this is a filter, like you can build the different filters based on whatever claims you have in a job. And we're gonna use a subject because this is the one that actually carries the SPIFFE ID. So I'm gonna say that this pool will be only for consumer that has SPIFFE ID from a trust domain acme.corp with a cluster Confluent demo. And it's, as you can see here, we're using this path. It's using namespace, Kubernetes code namespace, and service account, which some of you might find familiar. So running in namespace consumer, and it has a service account, Kafka consumer, if I remember. Condition. Let's do starts with a bunch of different conditions you can have, and then you need to specify permissions that's coming from service account that's already created before, and you can validate and save all this stuff. So now we have a pool. We need only pool ID in the next part of the configuration. So remember, so this is like consumer part, and so this is what I showed you in the slide. Endpoint URL, it's the same that you've seen. The only thing we need to change is here is a pool ID that I just created, and cluster is the same that it's been before, and we only want to add couple of things. We want to have this additional container in a pod that will be a proxy, and want to use a different configuration. I call keyless, and to make sure that it's not using any username and password. Comment it out, and now if we go to tilt, here's an interesting part. You can see from a log that it got principal, and we can see a SPIFFE ID, Confluent demo, namespace consumer, service account, blah, blah, blah. So I just connected it, authenticated actually with the Confluent managed Kafka using their JOD provide from a SPIFFE with like 0 changes in a code, only configuration changes. And how do we know that it is all working? So I'll just restart producer so it start kicking off something, and you can see that it's getting some records here. Oh, excited. We just moved the bytes over the wire. So it's pretty much it. It's super simple when you look at a slide. It's like this, but there's lots of different layers up and down. But exciting part, you can do this. You can get rid of all secrets that you have with Kafka, not only using MTLS, but also using things like JOD SVID or JOD pretty easily. And here's some links on this slide, and the slides will be available later, so you can click on them and see all the demo, can see all the different code examples. Right, that's it.
And quick question, like, what is trust model between proxy and consumer?
Trust model, they're running in the same pod, basically. Yeah.
What is a blast radius if the pod itself is compromised?
Blast radius of what?
Can we use that SPIFFE proxy to get identity for some other pods?
You'll get only the same identity for the same pod. You can't get identities for anything else beside this. So it's essentially the same thing if you compromise. So if you use an API keys instead, if you compromise the same pod, it's actually even worse because you can use it from anywhere else. In this situation, because you're using short-lived tokens, if you steal it, you can use it for the lifetime of the token only, or you need to have persistence in the cluster, which is worse. Any other questions? Any questions on the Zoom? I didn't move there.
Room seems empty. Like two questions at least.
All right, awesome. Thank you so much, everyone. And